Hi, I'm Chris Eckel from Millennium Technologies, and we're here today to talk about four-stroke heads and repair and pros and cons of some of the parts and things of that nature. Kind of a switch in the motocross market has been from two-strokes to four-stroke engines. It was always dominated by the 125 and the 250 two-strokes, and it's kind of switched over to the 250 and the 450 four-stroke engines. The wear parts and the things that go wrong in those engines are kind of different. It used to always be the piston and the cylinder and the two-stroke, and now it's kind of switched over to being the head and the valves and parts of those cylinders. So we've followed suit and currently do repair these parts so that we can try and save you some money when you do have a failure. We'll talk about the head itself and what we can fix and what we can't, and what it looks like first. I mean, this is a standard Yamaha 250 head. A lot of times you'll have a problem with a spring or something like that, and we'll drop a valve and have some chamber damage. And this is kind of what we're showing here is so a chamber that's been all dinged up, and kind of what we do to fix it. Once it's in this situation, don't throw it away. A lot of people will tell you to do that, but they're absolutely fixable. So what we do is we take the seats out and go ahead and weld the chamber up. We have a 5-axis CNC machine that will recut that chamber, and then we go ahead and put new components in and make it as good as new. And in some situations, and we'll talk about that later, we can actually make it better than it was when it was new. The areas that are commonly have an issue. Things we can't fix. We always want you to make sure that you don't send us something that we're going to tell you to throw away. Any damage in the cam saddles, anything in here, anything in these buckets, the bucket bores where the springs ride, any damage in that area, you pretty much need to buy a new head, because the repairs to fix it cost more than these heads do. As long as it's damage on this side, we're good to go and we can fix it. And a lot of times, you'll have them ported, and like this one is somewhat ported, and you can go ahead and save all the money that you invested in the porting, because we'll cut the chamber in and be all set. That's what we've changed and what we're doing. Once we get involved in this and fixing this head, we can make some changes to the materials that are used. The OEMs tend to use materials that are inexpensive and or last a long time, but might not be what you want from a performance standpoint. Unfortunately, there's competing forces inside a four-stroke head between getting the most power, the most performance out of it versus the most life. Certain components will last forever, but will not give you the performance that other ones will. And so that's kind of the trade-offs. Yeah, if you look at some of the top motocross engines, the Chad Reeds of the world and that kind of stuff, you'll see that they don't run the head that comes straight out of the box. They're able to, they'll put different seats in it, they'll put different guides in it and do things that we can do for you and give you as close a approximation of what he has when we're doing this fix, or we can do it without doing the fix. Not only, on a two-stroke cylinder, the preventative maintenance was changing the piston and putting a new piston in it. Here, it's actually doing a valve job and checking everything to make sure that it's still good. All services that we do, but you can check our website for all those things. The differences and the questions that you'll get asked if you do decide to send a head to us is where you want to go and what you want to do. Most of the motocross cylinders and a few of the ATVs will run a tie valve. I mean, that's the first and probably the thing that you can choose to use or not use. The tie valves are very light, and again, as a rule, you want to try and reduce as much weight as you possibly can, and anything that's moving, anything with extra weight will rob horsepower. So the less weight you can get in a part and still keep it strong, which is what titanium is, the better you are. The drawbacks to a tie valve is that they wear faster, and you'll find that that's similar with everything. So they wear out faster. Can't repair a tie valve or do some maintenance to it to keep it running. When it's damaged, when it's bad, you throw it away and buy a new one. There's levels of titanium valves depending on is it a cast tie valve, is it a forged tie valve. The stock ones are usually the cheapest ones. You can get better full-on racing valves from people like Axeldyne and places like that will have better shapes on the valves to give you some more performance. They'll they're made out of stronger materials. So that's stuff that you can do. When a valve is worn, I mean, it's either bent, obviously throw it away, or the face. There's a face right here that actually rides on the seat. That's what seals the head. After a while, this will get cupped. If it's cupped, it's leaking, you have problems, and you again throw the tie valve away. An option, and what they use in a lot of the ATV 450 heads and things of those, is a stainless valve. You can convert any motocross cylinder over to a stainless valve head. The advantage of it is that it wears a lot better. It will take more heat. You can actually go in and grind that face and get some more life out of the valve after it has been cupped. It doesn't cup as easy as a tie valve does. The only negative thing with it is it's about twice the weight. So it will rob some horsepower. The average rider, trail rider, the guy that's riding on the weekends, you'll never notice the difference. Some people want the best, and tie valves are the best. The stainless, again, the other major advantage with stainless is it's cheaper. It's, in some situations, a fifth of the cost of a tie valve. I mean, some of these tie valves can be $160 a piece, and the average stainless valve is 30 or 40. So you can save yourself a lot of money, and in situations where they're not revving them to the moon, it's a good situation. I mean, this is the stainless valve has been the valve of choice for years and years and years, and just recently, when you get above 11, 12, 13, and even higher, 1,000 RPM, that's when the tie valves come in handy. The other thing you need to do is use a different spring. If you're going to a stainless valve, you need a spring that's got more compression, more power to close that valve. A lot of times the stock spring will not control that valve at higher RPMs unless you've got a better spring in. We always recommend, again, that's another thing and another performance thing, is the more you can control this valve, keeping it open and closed that when it's supposed to be open and closed, the better performance you'll get. This is an OEM spring. They tend to be made out of the cheapest material you can get, and are relatively light in the pressure that it takes to close it. The lighter the valve, the less pressure you need on the spring, which makes it cheaper for them to manufacture. A high performance spring is made out of a better material. Every time that you compress one of these springs, you're reducing the life of the spring. But the better the material you have, the more times it'll compress. The other thing is, if you notice the springs, those are both for the same motor. One's a lot taller than the other. Another thing that four-stroke guys will do is put different camshafts in it. So you may need to adjust your spring for a camshaft. That's some of the difference. But again, with springs, the important thing is the material. You want a better material. A PSI spring or something like that is usually a very good spring. It's made out of the best material they can get, and will actually put more pressure on the seat to close this valve on a regular basis. So that's the important thing with the springs. But typically, like again, the OEM springs are good. They're going to work fine for most applications, but you have options on what you want to do. The main area, and the nice thing is, it doesn't cost anything more from a assembly or when we do the work. It's just a choice you have. In some situations, you don't have a choice. We just have to go with the aftermarket parts. But is the seat, where the valve is hitting, and then the guide, which is holding it in place. These two parts are integral, and they are the wear parts in the head, other than the valve face. The whole trick with keeping the spring and everything else lasting longer is to try and remove the heat from the engine. That's the thing that'll kill, or they call sack out a spring, faster than anything else, just getting them really, really hot. It'll reduce the amount of times that it can squeeze back and forth and hold its closing pressure. So there's different materials. Cast iron, which is what this is very hard. It's a very, very hard material, wears extremely long, will last a long time. The problem is cast iron holds heat. That's why in a cylinder they've gotten away from cast iron liners, is because they hold heat, and they will cause issues that way. So they've come up with different materials. There's copper beryllium, there's nickel bronze, but they're all gold in color. Copper beryllium is the best to use because it's almost as hard as the cast iron, and it transfers heat very well. The problem is the beryllium is a carcinogen and nasty stuff to work with. So what they've kind of done is just switched over to a nickel bronze. It's not as hard, but it's close, and it tends to transfer heat real well. The other advantage of it not being hard is that when this valve hits against it, it doesn't ring. It gives it a little cushion, a little shock absorber for the valve, and tends to keep the seat lasting a little longer. Problem is that it's softer than the cast and it wears out. So your life on these is less, but you can get more performance out of it. You'll end up wearing out seats and not breaking or damaging $160 valves, because these are $15. It's kind of what you want to save. Guides are the same thing. You've got cast iron guide, and you've got a nickel bronze guide. The cast iron is what comes in OEM. They're brittle. They wear forever. If you drop a valve or break something, you're going to crack these. And we'll replace one at a time just to maintain it. It's tricky. Like I said, you can break them pretty easy. We recommend and like the nickel bronze ones because they don't seem to wear anywhere near as bad as the seats, and they transfer heat better and do all the things, because this is closest to the spring, so you want to get rid of the heat as much as possible. We always like the guides that have this little lip on it because it will set the height in the cylinder the right way, and it works well. But again, we always recommend to use these if they ask, and we like the material because again, the cast iron is hard. It wears the stem on the valve, and it'll do some things that you're replacing valves and doing things. I mean, they last forever, but again, when they fail bad. Instead of these where they'll just kind of smear or wear out, and you can push them out and put new ones in and fix it. That's the main areas or things that decisions you can have. So kind of in a recap, if I was setting up the absolute best Chad Reed style head, I'd use a good quality forged titanium valve, and then a nickel bronze or copper beryllium seats and guides. That will give you the best wear resistant chrome moly spring that will last a long time, and you'll have a head that you don't have to worry about over revving or having some problems, because it'll last. It'll do what it needs to. Again, unfortunately, 4-stroke heads, you need to look at them. Some manuals say every 10 hours, some say every 20 hours. It's kind of different. With the stainless, you can go a lot longer, but it's one of those things where you need to keep a close eye on it, because if you don't do proper maintenance, you're going to end up with very expensive failures. With replacing all these parts, you could be close to $1,000 to just in the head, and that's not including a piston or a cylinder or anything else. So it's good to keep a close eye on it and do the proper maintenance and look at a good sign of when your seat's wearing out is when you start needing shims and having to do those maintenance level issues in your head. So hopefully that answers some questions on tie versus stainless and what materials to use in the head, but feel free to give us a call, and we'll discuss your specific needs whenever you have them.